pre-algebra friends. I'm trying a new program right now and I wanted to check it out. Hopefully this will work out well for me recording videos a little bit easier on my iPad. Go ahead and turn to page 123 in your book, and I will be able to talk you through this problem and how we are going to work on constant rates of change. All right. So we're going to look at discovering proportional relationships, and we're going to use this bar graph to help us determine how far the tortoise is going to walk. And it says use the bar graph to determine how many inches the tortoise travels in the third second. So looking at this, we know that 1 second he traveled 3.5 inches, the second he did 3.5 inches, and the third second should also be 3.5 inches. Perfect. So we know that he travels another 3.5 inches for a total of, looking up here, 10.5 inches total. So they can take that and put all that information into a table. So the first first second, he would go 3.5 inches. It's tough to write with this stylus on such a tiny block. Let me see if I can make it bigger. Nope. I can't. So we're just going to work with it. The second would be a total of 7 inches. The third would be that 10.5, which we saw up there. The fourth second would be, add 3.5 to that, we end up with 14. And then the fifth second would be, add 3.5 again, 17.5. Notice that he's going at a steady pace. We're going to call that a constant rate. He's going at the constant speed, or constant rate. Okay? So for each column of the table, write a rate that compares the distance and the time. Put the distance as the numerator and the time as the denominator. And we're going to write the fraction. So essentially we want to say he's going 3.5 inches per second, per 1 second. And so if we did that, 3.5 over 1, pretend that this is in here, it's too hard to write for it. We would say that we could simplify this into 3.5 inches per second, right? Okay? And it would be 3.5. Now, over here, we could do 7 inches per 2 seconds, and if we simplified that, it would end up as 3.5 inches per second again, and the decimal point would be 3.5, and if we did the same thing with the 10.5 divided by 3, then we would end up with the same thing. It would be 3.5, 10.5 over 3. Let's make sure we have units here, inches per second, and we would end up with 3.5 if we used a calculator for that. And what you're going to notice is all of these forms, the decimal forms of these rates, are going to be 3.5 if we continued. Same thing with 14 divided by 4 and 17.5 divided by 5. So a unit rate, use the unit rate to describe how the distance the tortoise travels is related to the time. Well, he travels 3.5 inches for every second, so that's our unit rate. And it's constant. It's going to stay the same no matter what. It's proportional. We call this proportional. When you have an equivalent decimal, equivalent fractions, all the way through wherever you check on a table or wherever you check on any sort of fraction that they give you, if it's proportional, then they will be the same throughout. Okay?